I am Andrey. I am a front-end developer at Kaliber5.de, where I specialize in Ember.js. I work there remotely from the snowy from Moscow, Russia, and I am really happy and proud being part of this amazing team. This talk is not really specific to Ember.js, so code samples and screenshots are in Ember, but the general idea applies to every front-end framework and even beyond that. So there are more than enough talks, articles, and even books written about BDD and Cucumber. So you will hear some of this today, but I would also like to share the nasty bits, how terrible Cucumber can be and how to deal with it. I will start with a brief introduction to BDD. We are all on the same page. By BDD, behavior-driven development, I do not mean the assertion style. I believe that you can do BDD with assert as much as you can do it with expect and should. And I do not mean this famous double loop workflow. You are supposed to write acceptance tests and unit tests prior to writing code. By the way, this does not mean that you have to do it in a waterfall fashion. So creating a full test coverage prior to writing any code is not feasible. And you're supposed to work in tiny iterations. You're about to write a line of code, come up with a small unit test, come up with a small acceptance test, write all three, then proceed in iterations. But my point is that you can do BDD even if you write tests after writing code. For me, BDD is team members.
Recording in progress.
Not only developers, but also managers, designers, representatives of the client if you're a consultancy, or product owner if you're a product company. BDD revolves around user stories, which are short text describing how a certain feature that you're about to develop is, how it works, how the user interacts with it. Let's have an example for a very simple feature. Let's say login and sign up. From the first glance, you might think that you need a couple of user stories to cover it, one for logging in and one for signing up. But then you remember about incorrect passwords, about malformed email addresses, about password recovery. So out of my head, I came up with this many user stories. These are just the names of the stories. So each item on this list should be backed by the actual story, describing how the user interacts with your app and what is the expected outcome. And it includes a few very rare cases, such as visiting a link from the password recovery email while being logged in, or while the link has expired. But if you don't think about such rare cases upfront, you might forget about them later, and your users will stumble upon it, and they will be unhappy, and your client will be unhappy. And typically, it's the developer to blame for forgetting about these, despite that the developer forgot about them as much as any other team member did. So the idea is that all team members converge and brainstorm those user stories prior to writing any code, prior to doing any actual work. And these user stories thread through the whole feature lifecycle, from the conception of the idea to deployment to production. After the user stories are available, the designer will use them as a reference to draw mockups, and the developer will associate an acceptance test with every user story. Those acceptance tests will be later executed on your CI server to deploy to production. This approach has a number of important benefits. As you have seen, it reveals the true scope of your feature and lets you estimate the time requirements more precisely. Certainly, you will never be accurate, but it prevents you from being overly optimistic, and your estimations will be incorrect with a lesser error margin. User stories serve as a specification for your feature, and as being a single source of truth, they have a power of resolving disagreements. You can create a separate issue in your issue tracker for every story, or you can create an umbrella issue for the whole feature, and user stories may be represented as items on a checklist or as subtasks. For us developers, it is kind of satisfying to check out those items as we make progress implementing the feature. But it's also important as an indicator for the whole team, meaning that when you don't have this explicit checklist and you develop the feature over a few days, your team members on the daily meetings you will be like, okay, today I am working on this feature, and the next day I am working on this feature. And your teammates will be like, why is it taking you so long? It's just log in and sign up. And with this explicit set of user stories, it becomes obvious what the real scope is, and it becomes visible how you make the progress. Also, user stories focus over users' needs naturally, as opposed to developers' needs. There is a book called The Inmates Are Running the Asylum by Alan Cooper. The name of the book is a metaphor for the fact that if you put developers in charge for designing the user interface and user interaction of your app, then app development becomes a crazy hospital. This is because developers are very prone to cutting corners and prioritizing geeky stuff over what is actually important for users. Finally, user stories integrate well into automated testing. And for this, you need a software library. I use Cucumber. The name Cucumber appeared like 15 years ago or maybe more. It was a working title, a placeholder for the project, but it stuck before the author was able to come up with something meaningful, so they decided to keep it. I have visited the GitHub repo of this project, and the first commit dates over 16 years back, as of September year 21. And Cucumber started as a simple library, syntactic sugar basically over another library, but later evolved into a full-fledged testing framework ported to most popular programming languages, especially the ones that are used for building user interfaces. JavaScript has the official Cucumber.js and Yada.js, which I happen to be using because when I started, there was a decent Ember.js add-on for it. And who knows how many more exist on NPM. In Cucumber, user stories become executable test files. So this file, the extension is .feature, and the syntax is called Gherkin. It unambiguously maps to an Ember.js acceptance test. The name of the feature is the name of the test module, and scenario names are test case names. Each scenario contains steps, one per line, which are executed sequentially. There are 3 types of steps. Given steps set initial conditions, initial state of your app. When steps represent user actions, and then steps make assertions. Of course, Cucumber is not an artificial intelligence, so you need to implement each step in your programming language, so JavaScript in our case. This is how it looks like in my code base. The original syntax of Yada.js is less convenient, so I came up with this like high-level abstraction. Basically, each step implementation is a function, And the step names in the feature file are calls to those functions. When a function returns a promise, Cucumber would wait for the promise to resolve. Sorry. And the test will pause until the execution of the app resumes, and then the next step kicks in. If you have similar steps, such as I should see 3 posts, I should see 17 posts, it does not mean that you need to implement 17 similar steps. This is thanks to the fact that step names in implementations are actually regular expressions. And for each capturing group in a regular expression, you receive an argument with a matching value. So in this case, the number of posts. This is a very powerful technique, but it's not very convenient. Firstly, because the regular expression syntax is notoriously difficult to read. And on top of this, you need those double backslashes because this is not a regex literal, it's a string, and the single backslashes are escape characters, so you need to escape the escape character. The second problem is that regular expressions return only strings. So if you need a number, you need to convert it by hand, which is not very convenient. Luckily, Yada.js, and probably Cucumber.js too, has a syntax called, they call it dictionary and converters, but I find this a bit confusing. I call this macros. A macro is a placeholder starting with a $sign. And under the hood, it gets paired with a regular expression to match and an optional converter function. So in this case, it would convert a number to an integer, but you can also do floats. You can look up DOM elements and receive elements as arguments. You can parse JSON, convert ASCII tables into data structures, and so on. Cucumber also supports test matrices. Matrices, like plural for matrix. Dude, perfect. So in Cucumber, test matrices require using placeholders as square brackets. You should use them in the name of the scenario so that you do not receive duplicates. And you use them naturally in both seeding steps and assertions. This scenario will be invoked multiple times, as many as there are data rows in the table of values below. Cucumber has a number of important benefits. First of all, the most important one, personally for me, is the separation of concerns. This means that all the pesky details, petty details, I think I meant, are hidden away from you, because like all those imports of libraries, specific helper invocations, seeding patterns, this is all visual noise most of the time. Typically, when you read through a test, you want to focus on its business logic and not those implementation details. So they're hidden away. You can work with the test on the high level. And this makes it more efficient, and at least my head does not overheat as much. Cucumber tests are readable for all team members, and all team members can participate in validating the tests, ensuring that they make correct assertions. Since step implementations are reusable, you can compose new tests by simply calling those steps in a different order with different arguments. So ensuring decent test coverage is very quick, and the test coverage itself also becomes better. Since those implementations are relatively short, it is easy to maintain them. You do not need to revisit them often. They're battle tested, reused in all sorts of features. So you rely on them without having to maintain them. Being part of the BDD methodology, it integrates well into your team's workflow and kind of enforces the workflow. Also, all the team benefits from the fact that tests are written in the same code style. You know how tests are given the least priority when code style is concerned, and reading someone else's tests can be very difficult. To be honest, when I read my own tests written like months ago, this is basically write-only code. I struggled to comprehend it because I did not put effort into structuring and organizing it. With Cucumber, this is not an issue. But this is too good to be true. Cucumber makes a lot of good promises and has an army of dedicated supporters, but it also has a comparable amount of haters. And many of those haters started as Cucumber enthusiasts after reading articles and listening to talks like this one. They managed to persuade their team to adopt Cucumber, spend weeks rewriting their tests, and then they get bitterly and utterly disappointed. Basically, every other claim is not fulfilled. And there are two possible outcomes from this. Either the team makes a tough decision to abandon Cucumber and rewrite everything back, wasting weeks and months of work, or as a Russian joke says, mice were bleeding and crying, but they kept eating the cactus. So the team may choose to keep using Cucumber, but they will stay unhappy about it, and they will keep frowning upon the developer who came up with the initiative. Guess who has been this developer on my team? But I did not give up. I figured that it is not Cucumber as software to blame for it. It's how we use it. I have an analogy for you. Imagine that I decided to try cooking, and I fail miserably cutting my hands with a knife, and I start preaching that kitchen knives are dangerous and everyone should abandon using kitchen knives when cooking. This would be ridiculous, right? So I identified the problems that Cucumber brings, and I came up with solutions to those problems. So today I will tell you about 5 of the most important ones. So these are my know-hows. Some are biggies, and they have been known. Like, I'm not the author of those ideas. I came up with them on my own, but they have been known for quite a while. And not all Cucumber supporters agree with them. Others just are tiny tricks. So let's start with problems. The first one is that the library of step implementations keeps growing and growing. Every feature requires some intricate logic. So you will end up both creating new steps for every feature and building on top of existing ones. When you improve, when your assignment is to improve an existing feature of your app, you will upgrade those steps. And this gets out of control very quickly because step implementations can vary across projects while step names remain essentially the same. It's very difficult to look up step implementations for steps. No IDE offers a way like to quickly look up an implementation. Regular expressions contribute to this problem. 2 step implementations can both, or even more than 2, can match the same step. So Yeda has a solution for this. Yeda would always prefer a more specific step implementation over a greedy regular expression. But this heuristics never works the way you expect. Like, you look at a step implementation and you expect this step implementation to be used. You don't even know that there is some other implementation that will override. Developers get lazy, and instead of looking for step implementation that will cover their needs, they end up quickly re-implementing a new one. And duplicates appear. They may differ in subtle details and phrasing and become a big problem. The second problem is that the step implementations are a black box. The step name can say something, but the implementation can do something else or nothing. Well, we did not have such extreme cases, but many times we ran into a case like this. Consider this example. It says there are 3 posts in the database. The title of the first post should be Hello World. Why is it Hello World and not, say, Lorem Ipsum? To figure this out, to make sure that this assertion is valid, you need to find and look into the implementation of the seeding step. And who knows what you will find there. The developer who implemented it may have used Faker.js. They may have hard-coded the hello world into every post, or they used fixtures. So you do need to reopen step implementations every time. I used to have, that's in the solution. Okay, so as you can see, another promise of Cucumber is not fulfilled. The third problem is that steps can be tied to each other. So they may be implicit coupling. This example is a bit artificial, but bear with me. It says the previously expanded post should contain a comment section. The problem is in the previously expanded part. This step implementation must know which of the posts on the page has been expanded. And what if like several posts are expanded in an arbitrary order? Yeda has a solution for it. All step implementations share the same this context. So the clicking step can memorize the DOM element on this, and the assertion step can read this DOM element and make the assertion. This works, but the problem is that it makes the feature file very tangled, and the implementation is very tangled. When you develop on top of it, you run into problems. In our apps, so we used this context very heavily, and when I first ran into it, I wasted a whole day untangling it and swearing and pulling my hair. So though this is a powerful feature, it leads to problems. The fourth problem is with presentational CSS selectors. They are a mess. A non-developer will look at this and assume this step is written in a foreign language. A developer understands that this is a selector, but they still cannot tell if it's a menu item, a sidebar element, or a post title in a list of posts. So you could say, let's solve it by using semantic selectors only. But if there is a technical possibility to cut corners, corners will be cut, especially when you are hotfixing something on production. So don't expect presentational selectors not to ruin your day. The fifth problem is with debugging. If you integrate Cucumber into your framework in the most simple way, it will offer 0 debugging capabilities. When a scenario fails, you will only see the name of the scenario, an unhelpful error message, and a meaningless stack trace pointing to some async stuff in Cucumber codebase. And again, you need to reopen step implementations, sprinkle them with console logs, debuggers, and so waste time figuring out what has happened. Now, 2 solutions. Those solutions may seem obvious in hindsight, but it took us a while to come up with them, and they're rather opinionated. So Okay, let's proceed. The first problem was the size of the library. I have realized that the user can do only this many types of actions on the page. They can click something, read from the page, they can fill text into the form field or read the text from a form field. They can select an item from a drop-down and such. You know this list from Ember test selectors. And I said, let's use only these highly reusable steps and never use any steps with logic specific to a certain feature. This reduced our step library from several hundred steps. Luckily, we did not reach the milestone of 1,000 steps. That would be a sad anniversary to celebrate. But anyway, so we are now down to a few dozen steps. 2 dozen are very reusable from Ember test selectors, and a few more are relatively rare, such as picking up an element from a power select using async type ahead search. But still, these steps are not coupled to any specific feature. The result is that it's easy to remember all the phrasings, and the steps are so tiny and atomic that you never have to reopen them. You just compose feature files, and you can copy paste step names because the same step names appear in basically every feature. The second problem was with hidden logic, and the solution is to extract all the truth hidden inside step implementations and expose them in feature files. So in the previous example, we updated by showing which specific seeding pattern we're using. And now it is obvious that the first post has the title Hello World and not something else. Previously, we were using a very elaborate seeding pattern based on Mirage traits, which were invoking Mirage traits. This seeding pattern was extremely complicated and large. It seeded like many hundreds of steps in every of our apps. And all tests were using the same seeding pattern. This meant that when I needed to implement a new feature, say I am adding comments to a post, I would improve this seeding pattern with more data, and this may break existing tests. Like I would create a post without comments, a post with a comment, a post with a comment and replies and such, and other tests fail, I need to fix them. The logic, the seeding logic becomes very complicated with if conditions and loops. By the way, Cucumber syntax does not allow if conditions and loops intentionally to improve the simplicity and readability. Instead, you're supposed to create multiple scenarios. And in our new practice, we use tiny seeding patterns. We do not seed any records which are not related to this particular test case. Here is another example. It says that a product should be selected on the page, but what does it exactly mean to be selected? And with the new approach, it becomes obvious. We're checking for the existence of an HTML class, which is responsible for the selected look. And we're looking for a comment section to appear inside the element. The problem with tangled implementations is solved in a very obvious way. We simply stop using this context and reference steps in the feature file. Though obvious, it took us a while to reach this, and it is unbelievable how much friction this solution resolved. With presentational CSS selectors, we of course rely on the Ember test selectors add-on, which tells you that you should use a data test attribute on every element that you want to interact with in your app. And now the step So it is now clear that we're clicking on a post title and not on a menu item. But this approach still has problems. It is still very hard to understand for non-developers, relatively difficult to read for developers, and presentational selectors can still be used technically. So I came up with a custom DSL I called labels. So I invented the syntax. I drop square brackets from this data attribute. I drop the data test prefix, and I capitalize what remains in order for this label to stand out in the phrasing of a step. I also reverse the order of compound selectors. So instead of saying data test post and child to data test expand button, I say the expand button of the second post. This is very natural, and it unambiguously maps to CSS selector. And I made it impossible to use the presentational selector. So anything but this specific syntax will not be recognized. And this made our test cases easy to read for non-developers and resolved another layer of friction. One problem arose with the nth child pseudo selector. It does not work as you expect it to. So when I say second post, I expect this post to be selected. But nth child does not work like that. It picks the second post from every immediate parent. So it's a wrong post gets selected, and more than one actually. So to solve this, I borrowed the idea of the EQ selector from jQuery. I had to implement it by hand. So what it does, it simply selects all posts on the page in a flat list, and then picks the second one from this list. I use indexing starting with 1 for readability by developers. And as for debugging, I created a custom wrapper function in between a cucumber test case and a QUnit test case. This wrapper would report all step invocations to QUnit. And when a step crashes with an assertion error or with an application error, this error will be caught, the error message will be enhanced, and the error will be rethrown. This is how the resulting output looks like. So for passing steps, first of all, you do see a list of passing steps, which is very convenient. The sneaker icon represents the step name as it appears in the feature file, and the gear icon represents the step implementation name that was picked for each step, and you can see that whether the pairing is correct. When a step fails, you again see the name of the step, the implementation, the meaningful assertion error, and the list of arguments that this step implementation was invoked with. For DOM elements, you do not see just array something, which is what you would see if you tried to cast an array of DOM elements to a string. Instead, you see that this is a collection. You see the label that was used in the step to make the lookup. You see which selector it corresponds to and how many elements matched. The stack trace is also more meaningful. So most of the time you will end up either inside a step implementation, or if the app crashed in the app code, you will have a reference to the app code. This concludes it. In Calibre 5, we dedicate some of our work time to open source causes. And I've been implementing the add-on I called Ember.js. It is still in active development. When it's finished, it will be a drop-in solution for Cucumber. So far, it's not yet usable, but I'm getting there. And I encourage you to visit the repo. I have enabled Github Discussions, which is a new GitHub feature. There's a more casual way to communicate in a GitHub repo while issues are being more strict. So please don't hesitate to chime in. As a conclusion, I found this amazing stock photo, which I believe summarizes my talk more than any other slide would. Thank you so much for having me, for listening to my talk, and I'm ready to answer questions.